Y equals sine x, and y equals 1 would be the line. First, we've got to find the point of intersection. We stop at the point of intersection. Y equals sine x is the sine wave, a maximum at 1. The line is right there. The enclosed area is with respect to the x-axis, so we want this area, so that minus that, so that is the initial picture. I haven't even drawn the axis of revolution. Right. Y equals 2. Good. The line y equals 2 is parallel to which axis? X. So in cylindrical shells, if we are revolving about the x-axis, the dx, the thickness part, should be dy. So we can start right here, and if you want to spin it this way, you want to find that area, then as you spin, the circle would be this, in this direction, so the cylinders you put are going to go this way. The cylinder's tiny thickness is dy, and that is the thickness that is going to spin and create the surface area. So, same logic, but we've got to do it from up there. Regardless of what the axis of revolution is, where should the cylinders be? I really gave you the answer, not the cylinder, the cylindrical shell be. Where should it go? This way or that way? If we are revolving about the x-axis, then the strip is it dx or dy in cylindrical shells? Dy. Okay, we'll start there. 2 pi is always out here, hanging out merrily. Radius, height. So the strip must be this way. Agreed. Okay. Now, if I pick a y right here, where should the height be? Or what should the height be? Should it start from here all the way up to there? Or should it start from here up to there? If this strip is not giving you a good idea, let's draw one in purple. Should be split up to it. Y1, Y2. Good. So the height of the cylinder, question to you, is it from the y-axis up to that line, or is it from the curve up to that line?
Are they not the same thing? The curve,
Raphael, why do you think that they are the same thing?
well, the height.
No, I'm asking, when you want the volume attained by spinning this area, you're trying to put shells, right?
Oh, yeah, then the curve.
Right, okay, the curve, not the axis. Right, so it's not from here to there, rather it's from there to there. Good? So, I pick some y. So, from that point to that point, what is that?
I think x minus f of x.
X minus f of x. Why is it x minus f of x?
Because your x is gonna be the whole thing, the whole strip, and then the f of x will subtract the rest. That's not in the
Okay. That is for my radius part. Good. So the height part is right here. What we want is this. Caleb is telling me that should be x minus f of x. There is one x, there is another x, x2, x1. So, what is the height of the cylinder? Right?
Pi over 2 minus sine x.
Pi over 2 minus sine x. Why is it pi over 2 minus sine x, right?
Because at pi over 2, the y value of sine x is 1.
Very good. When x is pi over 2, y is 1. The total distance right here is pi over 2, out of which you take away x. That height has to be pi over 2 minus sine x. Good? Okay. So, no matter where I move, if I move over here for some x, pi over 2 minus x. Agreed? I think that's probably what you meant by
It
this.
wasn't.
Wasn't? Okay. At least you admit. So pi over 2 minus sine x. Good job, right? Do you have the answer? Did you try to help or not? Good, good thinking. 2 pi. Okay, we need the radius, we need the bounds. Well, we've got to integrate with respect to y, so what are the bounds? Caleb?
0 to 1.
0 to 1, why? Y is y between 0 to 1. The curve is going from 0 all the way up to 1, and whatever area that we have starts at 0, goes all the way up to 1. So 0 to 1. That leaves us with one thing, radius. What is the radius? So if I put a shell here, that is going to be the radius. And if I move it up here, different color perhaps. If I move to the next strip, the radius will be that. Yes. That is the radius for the blue strip, radius for the purple strip. Blue cylindrical shell, purple cylindrical shell. Hint, we have picked arbitrary y1 and y2 on the y-axis. Maybe. Do you know the answer?
No.
Well, try. You might have something.
Okay, can you say it again?
Huh?
Can you say it one more time?
What is the height? So this strip is for y1, yes. The radius for that strip is from here to there because we're standing about y equals 2. So I want to know what that radius is. The hint is we picked arbitrary y's, just like we picked arbitrary x's on the x-axis.
I want to say 2 minus y1, but I don't know.
So Megan says 2 minus y1. Okay, so that is for this one?
Yeah.
For this one, 2 minus y2?
Yeah.
Okay. Bryce, do you agree? Anyone else disagrees, agrees? Agree, okay, I do too. 2 minus y1, y2, arbitrary y. Okay, got 0 to 1, we have 2 minus 1, we have pi over 2, but there is that sine x. We can't have x.
Isn't it just arc sine y? Or sine to the negative one, y equals x.
Sine inverse.
So Carter says, well, isn't that, so this would be sine inverse of y?
Well, just the sine x part, right?
Oh, the sine x part would be sine inverse of y.
Yeah, power of 2 minus. That part, or no?
You tell me.
I don't know, you look confused and I look confused. I think we're both confused.
I'm not looking confused, but look at that, look at this, and tell me why you're saying sine inverse of y.
I'm scared now, I don't know.
Okay, that's fine. Any other answers? Raphael?
Are you trying to get him to say it would be, because I don't even know, I'm thinking it's wrong, probably about y over sine.
What did you say?
See,
What
that's what-
over
that's-
sine?
I'm making me seem like I'm wrong now, but I agree with him originally.
Okay, sine inverse of y. Okay, I see.
I agree too, because if you take sine inverse of y, you get x, because you
Mhm.
reverse the y next time.
You give him
Okay.
x alone, so you get
But
it.
you're not like substituting out only y or x, you don't have to solve for x because sine x already equals y.
Thank you very much. Sine x is y, right? Why bother? Sure, Carter did think it right at the beginning. What Carter was trying to do is, Raphael, but the way you put it, the divide by sine,
Yeah, that was totally wrong, I agree with that.
completely bad language. Divide by sine. Y equals sine x. So Carter suggested, oh, well, we can do sine inverse of y. This way, we get an integral fully in terms of y, we can integrate, right? You plug that in there, you have sine inverse of y. Those two will get cancelled, that would just become y. But why go through all that, get it? Why go through all that work? I know sine x is y, right? Why bother? Good. So I can replace this by 1. So I had an integral that had an x component, got rid of the x component, entire integral in terms of y. We can now integrate this easily. Agreed? Go ahead and integrate and tell me what answer you get. Okay, just to recap, we have sine x, we simply replaced it by y, and this step is not necessary. 2 pi, 0 to 1. The only way to integrate this time is to FOIL and integrate. 2 times pi over 2 is pi. 2 times y, with the negative, minus y times pi over 2, minus pi y over 2, minus y times minus y plus 1. One thing that I noticed as I went around is making this more complicated than what it is actually. You have individual terms, all you have to do is integrate and apply the bounds. A mistake that people make is in simplifying, trying to combine these two. I appreciate the thought process. If you have like terms you want to combine, that's what algebra states. But the objective here is to integrate and evaluate. Will the answer change if you integrate it directly? When compared to simplify, then integrate? No, it is the same answer. So keeping it as is better. Yes.
It's y squared, isn't it?
Yeah, thanks. Oh, no, it's not that. But thank you. So don't make the problem more complicated than what it actually is. So 2 pi and parentheses.
Yes.
You're not using them, which is why I'm making mistakes. Keep the 2 pi outside. Pi, integrate, you get pi y. Integral of y is y squared over 2. You multiply by -2, so you have negative y squared. Negative pi y over 2 times dy. The pi over 2 part is constant. Integral of y is y squared over 2. Integral of y squared is y cubed over 3. Lower limit is 0, upper limit is 1. Every single term has y in it, so lower limit would just give me 0. Don't care about it. I'm still keeping that pi out. Plug in, you'll get pi minus 1 minus pi over 4 plus 1 over 3. Pi minus pi over 4 is 3 pi over 4. Minus 1 plus 1 over 3 is minus 2 over 3. You can combine this further and simplify 2 pi. 9 pi minus 8 divided by 12. Pi times 9 pi minus 8 over 6. Good. What is the crucial piece of this problem?
Parentheses.
True, but aside from parentheses, the key part to get into the correct answer, sure, you have to integrate things properly, etc., etc. But fundamentally, what is the most important step?
Drawing.
That if you don't get this setup right, there is no way you're going to get to the correct answer. Okay? So we want to find the volume using cylindrical shells. The two functions are y equals ln of x plus 1, y equals ln 2x minus 3. They should form an enclosed region. Whatever enclosed region that you get, you are going to spin that about 9, x is equal to 8. Okay, it all starts with the setup. And of course, in this case, once we set up the integral, we'll know whether we need to know the integral of natural logarithms or not. Okay. Ln of 1 plus x. When x is 0, it's ln of 1, so start right here. It's going to go that way. And the other curve, ln of 2x minus 3, is not going to start until x is equal to 2, at which point it's 0. It's going to go that way. It's just an approximate picture, so don't take it seriously. The line that I have is x is equal to 8, which is a vertical line. That is my axis of revolution. So the enclosed area is right there between those two curves. This is an open space. You're not integrating an empty space. So the point of intersection is equal to 4. You can simply set ln of 1 plus x equal to ln of 2x minus 3. Logarithmic equation, exponential on both sides, you get 1 plus x equals 2x minus 3. If you solve, you would have x is equal to 2. So when you plug in, did I say 2? 4. X must be 4. When you plug in x is equal to 4, value of y is ln of 5. And if you did 1.6, I'm just going to keep it as ln of 5. Good, that's my first step. Next, setting up the integral. Difference between Washer method and cylindrical shells. Washer method, if you spin about the x-axis, the strip would be dx. Spin about the y-axis, strip would be dy. Cylindrical shells, they are the opposite. You spin about the x-axis, the strip is dy. Spin about the y-axis, the strip is dx. Here, I'm spinning about an axis that is parallel to the y-axis. It is no different from spinning about the y-axis, just shifted. So 2 pi, spinning about an axis parallel to the y-axis. So this has to be, is it dx or dy? Good. Okay, now that we've got dx sorted out, we can find the limits of integration. What are the limits of integration? Start at 0, go all the way up to 4. Agreed? Okay. Next step is to find the radius and the height. Once we do that, we are done. But one thing to note here is this point. The curve in red starts at 2. Agreed? So up to that point, there is nothing below the blue line. It is just the axis, correct? This method here, Washer method there, put together in cylindrical shells. Good. But this is a special case of Washer. When you do this, you will have 2 pi split 0 to 2 will be the first piece. The second piece, 2 to 4. But regardless of the split, the process of height and radius will be the same. So I'm going to draw my first strip. I'm going to draw one here, draw one there. Call that x1. There is my strip. X2, another strip for reference. Good. When I go from 0 to 2, what is the height? Well, the radius is this way, height is that way. for an arbitrary value of x, the height is up to that curve. Do we agree? Anywhere I move between 0 to 2, it's from the axis up to that curve. So I've got the height sorted out. That curve is simply ln of x plus 1. Good. Radius over here. Well, no matter where you put that strip, the radius is always going to be the same both for the first integral as well as the second integral. Why? Well, radius for x2 is that flat line. So the total length is 8. That is x2. What is that length? 8 minus x2. Oh, great. Likewise, total length is 8. That is x1. What is the radius? 8 minus x1. For any arbitrary x, it is simply 8 minus x. So, radius here would be 8 minus x. First part. The second part, there's a reason why I picked this problem. Almost done. Second part, the radius is not going to change. Do you agree? The height is what is going to change. Between 2 and 4, the height is that length between the two curves. Top curve minus bottom curve. Same over here. Top curve minus bottom curve. So, top curve is top curve minus bottom curve, height, radius is still 8 minus x. That part doesn't change. You just have to distribute and integrate. Good. Now, integral of natural logarithm of x is simply s natural logarithm of x minus 1. We haven't gotten to that part yet. But there is a problem here. You have x multiplied by ln of x. How would you go about integrating this?
I throw an E in there.
Huh?
I throw an E in there.
You'd probably throw an e. You can't just arbitrarily throw an e in there. If that's the case, I would throw myself into a different galaxy.
No.
So you have a function multiplied by another function. We know one of the ways to solve that, which is U substitution. But to do U substitution, take the derivative of 1. It's got to be somewhere you set U to be some function. The derivative must be there. It's not there. Yes? 2 functions multiplied together. The only way to integrate this is integration by parts. So when we come next time on Wednesday, I'm going to start integration by parts, get the solution. So don't lose it.